in this very short video, let's go prove theorem number 13 that we are about to use on example 4 to differentiate a whole bunch of functions. But before we use it, let's try to prove it first. Okay. What is it saying? Theorem number 13 is saying if you are differentiating log base a of x, and that can be anything like log base 2 of x or log base 8 of x, then the derivative is simply going to be 1 over x times natural log of a. So if I'm just using it on example a, I can just use it. I can say the derivative of log base eight of x, that is going to be 1 over x times natural log of 8. How did I know that? I just used the theorem. But why is this true? So I want to show you the why behind this, because we can easily prove this before we use this down here for practice. Okay? So I'm going to use something called the change of base formula. Change of base formula. So quick review of Math 161. Say that we have log base 3 of 10. I just made it up. That is the same thing as natural log of 10 divided by natural log of 3. Okay? Another example. What if you have log base 2 of 47? Well, then you can write this as natural log of 47 divided by natural log of 2. Okay? So that's what change of base formula examples would look like. So if I'm using that to rewrite this log base a of x, what's that going to be? I am differentiating natural log of x divided by natural log of a. Okay, so the step number 1 was to use the change of base formula to write this as natural log of x divided by natural log of a. So if you have it in this form, what we will do is we're going to separate these two. I will separate these two. And I'm not taking the derivative just yet, but I'll write this as 1 over natural log of a. Okay. And then I'll say that is getting multiplied by natural log of x. Isn't that the same thing, right? Okay, if I'm multiplying, I can just put this back up top and we go back to the same exact fraction. But now, I want you to look at this one. 1 over natural log of a. That is just a constant. A is just a number, right? So 1 over natural log of a, it doesn't have any x anywhere. So we can go ahead and just pull this out to the front, okay, and deal with the other part. So let me just bring this out to the front, okay? Because that's just a constant. So I am going to write 1 over natural log of a, patiently waiting outside. And that's going to be multiplied by the derivative of natural log of x, the only thing that's left in here, okay? So I'm still writing down 1 over natural log of a. But you guys know this one now. What is the derivative of natural log of x? Isn't that just 1 over x, isn't it? So if I multiply these two together, these two fractions, oh, whoopsie, sorry. Where did that go? If I multiply these two fractions together, I will have 1 over 1 times 1 is 1. And I'll put this x in front of natural log of x, okay? Just the order of multiplication. It doesn't matter. So I'll put the x first. And that's getting multiplied by natural log of a. And if you take a look, isn't that the exact same thing they have for theorem number 13 there, right? So by change of base formula and knowing that the derivative of natural log of x is equal to 1 over x, we were able to prove theorem number 13. So in my next video, I will come back and show you a whole bunch of examples on example 4.